Hello everyone, this is Vahid, Research Fellow at University of York, and now I'm going to explain a demo for small cells and using a machine learning method to flow the traffic from non-utilized cells to the ones that are more appropriate. First of all, we are going to take a look at the scenario configurations here. And all the cells that has been used here is near radio, and bandwidth is 20 megahertz with numerology of 0, and other configurations can be seen here. And it's in the MIMO mode, and also this is the user group. As we can see, the slice that has been used is EMBB, and number of the users 30. And now we are going to run the simulation. And before running the simulations, I'm going to explain our X apps here and what's going to be done for with that. This Python program, it's as an intelligent control system. It's designed to manage operational states of this multiple 5G cells within a radio access networks, and primary function is to monitor the performance of each cell in real time and then deactivate those that are underutilized, optimizing the network resource usages and reducing unnecessary energy consumption. Specifically, the programs analyze the throughput and also PRBs in the usage metrics extracted from the VIAVI cell reports through an InfluxDB query through the REST full API. And when both metrics for a given cell fall below the, let's say, predetermined thresholds indicating that low data traffic and minimal resource usage, the program issues a command to disable, again through the RESTful API, to disable the antennas by sending a mask of the zeros to deactivate that antenna. This action also forces in any connected user equipments to hand over to the appropriate ones that it's going to be predicted by machine learning approach, more active neighboring cells, and maintaining the network efficiency. And the program also continuously runs in a loop, let's say polling the data every 10 seconds to, let's say, reassess each cell state. And if a previously disabled cell begins to show higher traffic for or PRB activities, let's say it means that if it predicts that it's going to have higher traffic or PRB activities, it automatically reactivate by applying a full antenna mask, enabling it to resume servings and user equipments. Its cell currents, let's say, on an off state is tracked to prevent redundant actions and ensure smooth transitions. And also the implementations include robust error handling and retry strategies to maintain a consistent communication with network and management system. Also, this except is structured to be scalable and let's say maintainable to allow or allowing the new cells to be added easily to monitoring frameworks. And let's start run the test, and in the meanwhile running the program. extracting the data. And as we can see, now we expect that some cells go on and off. Users are moving, and we expect to have some cells on and off. So and as we can see, the cells went off and the users are hand over here to the other cells, appropriate cells. And we can see we have some overloaded cells, and when it's going to having a low value cell that's less than 20% of the resource blockade, resource block usage, it's going to be off. Now it's going to be on because there are some loads and the user equipments hand over or reach to the cell area that can be supported by that cell. And now this is the simulation durations. We are within a targeted user equipment cells, and the features that here has been used, that's the PRB usage and also a number of the user equipment connected. It's the throughput and loads of the features, and it's a neural network based approach. And now we can see that these cells went off, and it's going to predict which cells is going to be off. And then as you can see now, most of these are off and has been overloaded to another cell with the highest energy consumption. And thank you for your attention.